Hi, this is our group demo video for Lab 8, creating custom chatbot with large language model and embeddings. In this lab, we built a complete group chat web application with fast API backend, MySQL database, real-time WebSocket messaging, and an integrated local LLM using lab8.cpp. Finally, we wrapped this web application into a mobile application using Android Trusted Web Activity. Everyone contributed to different steps of this lab, such as testing the code on our own laptop or set up the Python environment, MySQL database. Whenever one member faced a problem, others provided guidance and support. I'll demonstrate how the system works, from backend setup to AI chatbot integration and mobile deployment. The part 1 is web application. First, we downloaded the zip file for this assignment and installed the MySQL server and set it up. Next is fast API setup. This is a screenshot for the MySQL setup process. Next is fast API setup process. As we showed on screenshots, first we went into the virtual environment on Python and activate. This is activate and install requirement text file. Then copy the text in the env example to env.example to env file and change some variables like the secret value. Then we entered this command into command line and ran the server. If everything goes correct, we open this link in the browser. We open this link in the browser. We can see a web page like this. Then we entered the username and password and click the sign up. We will see the chat window. But now if we send any messages with a question mark, it will send this back LLM error because now the front end was trying to connect to fast API backend WebSocket server, but the connection could not be established. So in the next step, we need to establish the connection, which is the step 4, configuration. In this step, we first edit the env file and copy and paste the lines into it. This is screenshot. Next, we need to build the llama.cpp using a bunch of command like git clone, cmake, and cmake cmake build config release. This is the progress of the release. And then we need to get a llama3 from this website. Accept the license and get the download link to download the model. This is the download link. And this is the website. We show the website. Here, this is the website. And after we download the model using this command, we can start the HTTP server. Then we can use the llama model to chat, but we still need to build connection to let our group chat use this model. So in the chat env file, we added the model path into the LLM model here. we added the path, and then we restarted the fast API, and then we can see after we send a question, it will give us an answer. From now on, part 1 is done. Hi, this is part 2. The part 2 is mobile application wrapper interface. In this part, we need to use Android Studio to get access to the group chat using HTTP and HTTPS. First, we download the Android Studio and set up the environment. Then we choose Android Trusted Web Activity directory and open it. Here's the screenshot. Then we open a build Gradle file and change the application ID and namespace. Then we need to set our deployed web URL in this file. At this moment, we use 10.0.0.2 colon H1000 because this is how the Android emulator works. This is a magic address that tells the emulator connect to the host computer's local host network. Therefore, if backend runs on PC at localhost 8000, the correct URL for the Android app is this 10.0.2.2. So we build and run. Then we can see the group chat on Android emulator here, but it is not secure. So we need to use the asset signing key. After run this, we need to use the asset links to solve this problem. First, generate and use the signing key. After run this command, get the SHA 256 figure print, copy it. Then in this JSON file, copy it, and then in this JSON file, the assetlinks.json, we need to paste the fingerprint in here and change the package name as what we entered in the previous file. Then we want our Android application to be accessible from the internet. So we need to expose the fast API backend to the public internet. That's where the ngROOK comes in. ngROOK creates a secure tunnel from a public URL to local server. We use this command ngROOK HTTP 8000. Then we get a forwarding link. This is the screenshot, the forwarding link. Then we copy the link into here, our strings.xml file. The package name in assetlinks.json must match our Android application ID, which is here. Namespace, the package name, and then we generate the signed application APK. So here we choose we select the build. We select the build generated signed application APK and create the APK. Next, here enter the password, the path, and click the next, and build variants, click the release, and click the create. Then we get the app a release.apk file. After that, uninstall the previous emulator and install this new APK. Finally, we can run the group chat on Android emulator using secure web link without URL bar. This is the screenshot, and this is the real project I can show here. Yeah, here. Part 2 is done.
Hello. Hello. I'm working for lab8 for the part 3. And here is what we're doing on part 3 is we need to do something, do some programming on embedding app.py. And here's what we're doing, and here's some function. Here is how we use the model. We use tiny llama model here for our LLM, and here we get how we get the PDF and how we get the PDF chunks. We set the chunk size is 500 and overlap 100. And here is how we get the vector store, and we're using the sentence transformer to build our vectors for our PDFs. And here is how we build our conversation about RAG. And yeah, this is how we're using LLM to read how the vector store we have already stored in the web page. And here's how we get the history. Yeah, that's all the main function. And after that, we can install the requirements and run the website. And this is what we get. It's a page like this, and we can browse the files and upload the PDF what we want to let the model learn the knowledge in these PDFs. Yeah, so every time we start this server, the model didn't know anything about this PDF, but after we uploading and we press process, this model will transform this PDF to the vectors, and they will learn something on these vectors. And here we can ask some questions and we can get the answers. And here's some history. After it's the history what we ask, and we can add something else, and it is loading, and we will finally get a response. Yeah, that's how we successfully deploy the modeling about how to export answer the certain knowledge in this PDF. Yeah, that's my part.
So in part 4, we made a small but really useful change to the backend. Instead of using FAISS like before, we switched to Chroma, because Chroma lets us save the vector database on the local machine. So that means now we do not need to re-upload the PDF every single time we restart the server. The data is already stored locally, so we can just start asking questions right away. And you can see here is the code changing. You can see we use the Chroma here and set a persistent directory, set where it saves all the vector on the disk. You can see it's here. So even if I shut down and restart the backend again, the chatbot still remembers all the content we uploaded before. And I also upgrade the prompt to the chatbot. So when it cannot find the answer in the factor database, it will directly say, I don't know. Instead, I'll make up some answers. And we have already fitted a bunch of Python programming materials, so we can just ask it, like, how does a list comprehension work in Python? And or something like how Python can handle exhibitions, and it can give us the answer directly instead of after we uploading the PDF. And of course, if you want to add more data, you can just upload a new PDF from here. Okay. And it will be processed, embedded, and stored in the same local database. Next time you come back, it will still be here. No need to redo it, the whole process. So basically, part 4 makes the system way more practical, faster startup, persistent data, and it's easy to grow your own knowledge database.